Good afternoon. Am I audible?
Yes, madam.
So in last lecture, we have solved numericals on how to draw influence line diagram for cantilever beam. Okay. And also we have solved numericals on overhanging beam. If left overhang provided, right overhanging provided, then how to solve?
मैडम आवाज येत नाही मॅडम जोरात.
Hello. Hello.
आवाज आहे ना मॅडम जास्त व्हॅल्यूम वाढवा म्हणा.
Okay, now am I audible?
Yes, madam.
Okay. So in last lecture we have discussed or studied how to draw influence line diagram for cantilever beam as well as how to draw ILD for overhanging beam. Okay, so in last lecture we have solved numericals on if one overhang is provided, then how to draw ILD. So today we will see if two overhangs provided at that time how to draw influence line diagram. Okay, so please write down next question. Draw ILD. Draw ILD for ILD for shear force and bending moment, shear force and bending moment at Z which is equal to 3 meter, Z which is equal to 3 meter from A. So this is the question. Now in this question, two overhangs are provided. Suppose this is beam. Here one simple support is provided and here also one simple support is provided. This is A point. This is B point. Okay, so here 3 meter and this distance is 2 meter. And this is total span L which is equal to 8 meter. L which is equal to 8 meter. So this is the overhanging beam. In this, two overhangs provided at right side as well as at left side. So for this, we have to draw influence line diagram. So first we will draw influence line diagram for RA. Influence line diagram for RA. Okay, so we have to draw here influence line diagram for RA. Yes, at which point value is 1, at which point value is 0. Yes,
For me,
A
value
point
1.
yes,
Point A1. Point A1.
point A1. Okay, then at B,
Zero.
0. बघा आता काय असणार आहे, we have to draw here ILD for RA. Okay, so here value is 1. We have to close it at B. From B to this overhang we have to make rigid. That's why we have to extend this line up to this support. Okay, and after that you have to close this. Now this side over. Now this side from A to D. Suppose we will mark here. This is called as, this is C and this is D. After that again from this A to D we have to make rigid. So we will extend these lines. We will extend these lines up to this and then we will join these lines. So this is the ILD for RA. Now we will write values here. So this is A point. This is A point. This is B point, this is C point, and this last one is the D point. So this span is 8 meter, here value is 1. Okay, and you have to find the value of here. So how we will find out? This is 3 meter. So this is the 1 plus A divided by L, that is 1 plus 3 divided by 8. So you calculate and tell me how much?
1.357.
1.37. Okay, now we will calculate this value. So this is 2 meter. So here this value is A by L, that is 2 divided by 8. So how much value will comes here?
0.25.
0.25. So this is the ILD for RA. After that, we will draw ILD for RB. ILD for RB. When we will draw ILD for RB, at that time, which point value is 1 and at which point value is 0?
RB1, RA0.
Okay, so suppose this is D point, this is A point, this is B point, and this one is the C point. So here at B value is 1 and at A value is 0. So here we will mark here value 1. Okay, and at A value is 0. So we will connect this. But from B to C we have to make rigid. That's why we will extend up to C and then we will close. Okay, now left side overhang is remaining. From A to D, one overhanging is provided. So we have to make rigid. So we will extend this A line up to this B line and then we will close this line. So this is the ILD for RB. We will mark values here. So this distance is 3 meter, this distance is 2 meter, this distance is 8 meter. Now here value is 3 by 8. You calculate and tell me accordingly. So here value is 1. So here value is 1 plus 2 divided by 8. And this is the ILD for RB. This is the ILD for RB. 1 plus 2 by 8, how much?
1.25.
1.25. And this 3 by 8 is?
0.35.
0.375.
37.
Okay, so this is the ILD for RB. Next, we have to draw ILD for shear force and bending moment. Okay, ILD for shear force and bending moments. First, I will draw original figure, then we will draw. So here, 2 overhangs given. We will mark here. Left side 3 meter and right side 2 meter. Okay, now Z is 3 meter from A. So this is A point. Z location is 3 meter from A. So we will extend this line also because of at the time of shear force and bending moment, Z line is required. So first we will mark points here. This is D point, this is A point. Suppose we will call as a E point, and this distance is Z, which is equal to 3 meters. So from this E to B, how much distance is remaining now?
5.
5 meter,
Five.
and this distance is 2 meter. Here support is C support. Okay. Now we will draw shear force diagram for this. Sorry, influence line diagram for shear force. So first we will draw baseline. First we will draw baseline. Now we will start from this A point. So A to Z downward diagram will be there. After that, from this point, line will go upward and this will close at B. But from B to C, we have to make rigid. So this line will continue up to C point and then we will close this line. Okay. After that, now you concentrate here left side. So from this A point, we have to make rigid this A to D portion. So we will extend this line. Okay, and then we will close. So this is the ILD for shear force. We will mark values here. So this distance is 3 meter. Here D point, this is A point, this is E point, this is B point, and this is the C point. This distance is 2 meters. This distance 5 meter, 3 meter, and this distance is also 3 meter. Okay, so we have to find out values here. So how we will find out values here? So here 2 by 8, which is equal to 0.25. Okay, so here minus Z by L, that is 3 divided by 8, which is equal to how much? I think 0.37, right? And here 5 divided by L, 5 divided by 8, which is equal to how much this value?
0.63.
0.60.
3.
63. Okay. And here 0.37. So here value is 3 by 8. Again here 3 by 8. So which is equal to 0.37. So this is the ILD for shear force at Z, which is equal to 3 meter from A. 3 meter from A. After that, we will draw bending moment diagram. We will draw bending moment diagram. So, not bending moment diagram, ILD for bending moment. Okay, so first we will draw baseline here. So, suppose this is baseline. First, I will mark all points here. So, this is the D point, this is A point, this is E point, B point, this is, and last one is the C. Now we have to start from A to B. So from this A to Z distance value will be there. So A to Z something value will be there. After that Z to B it closes, and from B to C we have to make rigid. So line will extend up to C, and after that we will close. Same here. From A to D, we have to make rigid. That's why line will go below, and after that we will connect. So this is the ILD for bending moment. Now here value is 3 into 5 divided by 8. 3 into 5 divided by 8. This distance is 3 meter. This is 3 meter. This is 5 meter, and this is 2 meter. Okay, so here this distance is 3 by 4. हे कसं कॅल्क्युलेट करणार? 5 ला किती असणार आहे तुमचं? 15 by 8. तर 2 ला किती असेल त्याच्यावरून 3 by 4 आहे तुमचं हे डिस्टन्स. आता मला हे डिस्टन्स फाइंड आउट करायचंय, तर हे डिस्टन्स कसं फाइंड आउट करणार आहे आपण? 3 मीटर साठी 15 by 8. So for this 3 meter, how much? That is 18 by 8 will come here. 18 by 8. So this is the ILD for bending moment at Z which is equal to 3 meter from A. 3 meter from A. So if two overhangings are provided, at that time you have to solve question like that. So you have to concentrate at which point we have to draw ILD. At that point one value will be there and 0 for remaining support. After that, if overhanging is provided, so you have to make rigid. That's why you have to extend only lines. Okay. So please take screenshots. We will solve next example.
मॅडम ते 18/8 कसं आलं ते सांगा ना.
18/8
8
कसं आलं? आता हे 3 मीटर साठी हे डिस्टन्स किती आहे तुमचं? हे किती आहे कॅल्क्युलेशन?
1.8 1.87
1.87. So for 3 meter 1.87. So for 3 meter how much? So 1.87 into 3 divided by 3. किती आहे हे डिस्टन्स बघा. वन 1.87 येत असेल ना.
1.87 यायला मग.
हा मग हे 8 ने 18 ला डिवाइड केल्यावर पण तेवढंच येते ना. म्हणजे 2.8 असेल ना. बघा इथे काय कॅल्क्युलेट केलं डिस्टन्स 1.87. For 3 meter this distance is 3 into 5/8. So for these 3 how much? Likewise you have to calculate. 1.87
18 divided by 8 केल्यावर 2.25 यायला मग.
नाही हे असं कॅल्क्युलेट करायचं सांगितलं त्या पद्धतीने. हे 3 साठी 1.87 for 3 how much? Okay, so till now we have solved examples on determinate beam. Okay, now we will see. Okay, I will draw here one figure and explain here. So suppose this is beam is given, and here support is provided, one support, second support, and third support. This is A, this is B, and this last one is the C. Okay. So here 10 kilonewton load is applied and here 15 kilonewton load is applied. This distance is 2 meter. This distance is 3 meter. This 3 meter. Now you tell me this beam is determinate beam or indeterminate beam? How you will identify this structure is determinate or indeterminate? So you have to count number of unknown reactions, which is equal to number of equilibrium equations, then this is called as determinate structure. This structure is called as determinate structure. That means we have to count number of reactions and movements, which is equal to number of unknown equations. ही condition satisfy होत असेल तर structure determinate आहे. If number of reactions should be greater than number of equations, then this structure is indeterminate structure. Now you tell me here how many reactions are there?
3.
3 reactions are there, and how many equations are available with you? For this particular figure, how many equations are available with you? 2 equations available with you. Summation FV which is equal to 0. And summation moment at any point which is equal to 0. So equations are 2 and reactions are 3. That means number of reactions should be greater than number of equations. So this structure is indeterminate structure. This structure is indeterminate structure. First we have to convert this indeterminate structure to determinate structure. So for this converting we have to provide one internal hinge. we have to provide one internal hinge. If we will provide here internal hinge, at that time this structure will be determinate structure. So we will break here structure at this D point. Okay. So likewise we have to solve for indeterminate beam. So we will solve this example here. Please wait. I will draw from starting and then we will draw influence line diagram. Okay, so AB, simply supported beam, here 10 kilonewton load is applied. Now here RA reaction will be there, here RB reaction will be there, and here RC reaction will be there. So this structure is indeterminate and we have to convert into determinate. That's why we will provide here hinge support, we will call as D point. This distance is 1 meter. Now this is 3 meter and this is 2 meter. So this is now determinate structure. We will draw this figure into two parts. Okay, we will draw this figure into two parts. Suppose from A to B, and here hinge support is provided. So here D point, this is B point, and this is A point. In between A to B, 10 kilonewton load is applied. This is 2 meter, this is 2 meter, and this distance is 1 meter. Okay, 1 meter. And whenever we will cut this, so here one reaction will be there, and it is called as RD, reaction at D. So this is the half part. Now I will draw this remaining half part here. Okay, so this remaining half part is here, 15 kilonewton load is applied, here 15. This is 2 meter and this is 3 meter. Now, suppose this is structure 1 and this is structure 2. So, which equation first we will solve? Which equation first solve करावं लागेल?
Second, madam.
Which equation solve करावं लागेल? First का second?
One.
Second, madam.
वन इक्वेशन जर सॉल्व केलं तर वन इक्वेशन मध्ये RA अननोन आहे, RB अननोन आहे आणि RD अननोन आहे आणि आपल्याकडे इक्वेशन्स किती आहेत? दोनच आहेत. जर आपण सेकंड इक्वेशन सॉल्व केलं तर ह्याच्यात अननोन किती आहेत? दोनच आहेत आणि इक्वेशन किती आहेत? दोन आहेत. सो वी विल सॉल्व फर्स्ट सेकंड इक्वेशन. सो summation FV which is equal to 0. So this RD going upward and RC going upward. That's why RD plus RC and this 15 kilonewton going downward. So minus 15 which is equal to 0. So RD plus RC which is equal to 15. So this is equation 1. We will apply second equation, summation moment at A which is equal to 0. Not A, moment at D. So this RC creates anti-clockwise movement. So RC into perpendicular distance is 5 plus 15 into 2 which is equal to 0. So 30 which is equal to 5 RC. Therefore RC which is equal to 30 divided by 5. So you will get RC which is equal to 6. RC which is equal to 6 kilonewton. Now we will put this value in RD equation and we will calculate the value of RD. So we will put here value. So equation first is RD plus RC which is equal to 15. So RD which is equal to 15 minus 6. So RD which is equal to 9 kilonewton. RD which is equal to 9 kilonewton. So from this, we will write the value of RD here, 9 kilonewton. Now here two unknowns are remaining and two equations are available with you. Again, we will apply summation FV which is equal to 0 for this first beam. So here RA plus RB minus 10 minus 9 which is equal to 0. So हे 9 कुठून घेतलं लक्षात आलं का? The value of RD. So RA plus RB which is equal to 19. This is equation first. Then second equation we will apply summation moment at A, which is equal to 0. This RD creates anti-clockwise movement, so minus RD into perpendicular distance is 4 meter. After that, this 10 kilonewton creates clockwise movement, so 10 into 2. And this 9 kilonewton creates clockwise, so 9 into perpendicular distance is 5, which is equal to 0. Now we will shift this minus RD to right side. So 10 into 2, 20, 9 into 5, 45, 65. Yes, 65, which is equal to 4 RD. So RD, which is equal to 65 divided by 4. Therefore, RD, which is equal to how much?
16.25.
Not RB. I think RB is there. This is RB. Huh? 16.25 kilonewton. Now we will put this value of RB in equation 1 and then calculate the value of RA. So we will calculate here the value of RA. So RA plus RB, which is equal to how much? 19. So RA, which is equal to 19 minus RB is 16.25. So RA, which is equal to how much?
2.75.
2.75 kilonewton. So these are the reaction calculations. Now, total load is applied here 10 plus 15. बघा हा इंटरनल हिंज प्रोव्हाइड केलाय पण लोड किती अप्लाय होतो ह्याच्यावर तुमचा 10 प्लस 15 दॅट इज 25. हा 25 लोड किती सपोर्ट मध्ये डिवाइड केलेला आहे RA, RB आणि RC. मग या तिघांची ऍडिशन केली तर तेवढी येते का चेक करा. RC 6 प्लस 16.25 प्लस 2.75. RA plus RB plus RC, which is equal to 25. तर आपण सॉल्व्ह केलं बरोबर आहे, अदरवाइज आपण काहीतरी मिस्टेक केलं. कारण लोड किती ऍक्ट होतोय 25. तो लोड किती सपोर्ट मध्ये डिवाइड केला गेला पाहिजे 3 सपोर्ट मध्ये. म्हणजे आपण हा जो 9 किलो न्यूटन काढलेला आहे तो 9 किलो न्यूटन हिंज आहे, त्याचा कुठल्याही कॅल्क्युलेशन मध्ये काही संबंध येत नाही. ह्या तिघांची ऍडिशन म्हणजे टोटल लोड असणार आहे. तर RA plus RB plus RC, which is equal to 25. Now we will draw ILD, influence line diagrams for RA, RB, RC, shear force and bending moment. So first I will draw here original figure, then we will draw. So this is suppose original figure. Here A support provided 4 meter span is there. So here B. नाही ना, हिंज म्हणजे तुमचा सिंपल सपोर्ट असतो. सिंपलला मूवमेंट असते ना, मूवमेंट फक्त फिक्सलेला असते ना. हिंज म्हणजे तुमचा सब सिंपल सपोर्ट. हिंजला दोनच रिएक्शन असतात, व्हर्टिकल आणि हॉरिझॉन्टल. बघा की हिंज म्हणजे काय असणार आहे, तुमचा हा सपोर्ट प्रोव्हाइड केलेला आहे, एक व्हर्टिकल आणि एक हॉरिझॉन्टल. ह्या कोर्स मध्ये इनक्लाइन लोड नाहीये, त्यामुळे हॉरिझॉन्टल ऑटोमॅटिकली इलिमिनेट झाला. शिल्लक कुठला राहिला तुमचा व्हर्टिकल. फिक्स्ड सपोर्ट असेल तरच मूवमेंट येते. RB, then this is RC, and we will mark D point. So this is A, this is B, this is C. This distance is 4 meter. Suppose this is D point. This distance is 1. So from this D to C, how much remaining? 5 meter. Okay, so this is the figure. Now we will draw influence line diagram for RA, RB and RC. You try. How we will draw these diagrams? कशा येतील डायग्राम बघा बरोबर आहे थोडं. RA ची काढताना कसा शेप येईल सांगू शकते का कोणी? First we will draw for RA. So first I will draw here baseline. Suppose this is baseline. Whenever we will draw for A point, at that time one value for this A point. Okay, after that 0 for B. Okay, after that from this B to D, one hinge is provided. So diagram will continue up to D only, continue up to D only, and after that here rotation is possible. So diagram will close here like that. Okay, so this is the ILD for RA. So this is A point. I will use different colors, so you will get A point. This is B point, this is D point, and this is C point. This distance is 1 meter, this distance is 5 meter, this distance is 4 meter. Here value is 1. So we have to calculate this value. How we will calculate? For 4 meter distance is 1. How much value will be there? See here, for 4 meter value is 1. For this 1 meter question mark. So 1 into 1 divided by 4, that is here value is 0.25. So this is the ILD for RA. After that we will draw ILD for RB. Now for which point value is 1 and for which point value is 0?
RB1,
Yes.
RB1, RA0.
RB1.
RBO.
RB1, okay. A ला 0 असणार आहे, so A to B. From B to D, we have to make rigid. That's why it will goes up to this point. And at D point, hinge is provided, so diagram will rotate likewise. So this is the ILD for RB. So here value is 1. So here you have to find out value, this value. Okay. So this is A point, this is B point, D and C. This span is 5 meter, this is 1 meter, and this is 4 meter. Okay. So for 4 meter value is 1. For 4 meter value is 1. So 4 plus 1. आता आपण कुठपर्यंत फाइंड आउट करतोय D पर्यंत म्हणजे 4 plus 1 येणार आहे. So for 5 question mark. So 5 divided by 4 value will be there here. 5 by 4. किती येते बघा? 1.25.
25.
So this is the ILD for RB. Then we will draw ILD for RC. ILD for RC. Now one value for which support here? One value for
C support.
C support. Okay, first we will label here A, B, D and C. Okay, so one for C. One for C here and 0 for D. After that बघा आता हिंज सपोर्टला 0 असते तुमची, मग इथं 0 झाली, मग 0 कडून B ला जाईल त्यावेळी 0च येणार आहे आणि B कडून A ला जाईल त्यावेळी सुद्धा 0च असणार आहे. So this is the ILD for RC. This is the ILD for RC. This value is 1. This distance is 5 meter. This is 1 meter and this is 4 meter. Then we will draw ILD for shear force and bending moment. Okay, so first I will draw here original figure. And now here two possibilities are there. So Z location in between A to B and Z location in between B to C. So first we will check for first possibility, that is Z location in between A to B. So we will mark here. This is our A to B span, AB span, and this is our BC span. here D point is located. This distance is 1 meter. This remaining distance is 5 meter. Now we will mark here Z location. Suppose Z at 2 meter. Z at 2 meter from A. So this remaining distance is also 2 meter because of total span is 4 meter. So first condition is Z at 2 meter from A. From A. For this we will draw ILD for shear force and ILD for bending moment, and after that we will check in between B to C. Okay, so first we will draw for this. Now we will draw ILD for shear force. कशी लो ILD shear force ची कोण सांगताय? First I will draw here line. Okay, we will mark point here, points. So this is A point, this is E, this is B, D and C. So first we will draw for this A to B simply supported span. So for simply supported span from A to Z minus L here. After that it will go above and it will close at B. But from B to D we have to make rigid, so we will extend this. Here at D hinge support is provided, so diagram will be closed likewise. So this is the ILD for shear force. So here distance is Z by L. So this distance is 2 meter. This is also 2 meter. This distance is 1 meter and this distance is 5 meter. So here Z by L, that is 2 divided by 4, which is equal to 0.5. And here also 2 divided by 4, which is equal to 0.5. Now we have to calculate this distance. How we will calculate this distance? This distance. कसं calculate करणार? For 2 meter, this distance is 0.5. 2 meter, 0.5. So for 1 meter, how much? That is 0.5 divided by 2. So this distance is 0.25. So this is the ILD for shear force at Z, which is equal to 2 meter from A. After that we will draw for bending moment. Okay, so same way, first we will draw here baseline, then we will mark point here. So first you have to draw for simply supported beam, and then you have to make rigid for remaining span. So this is B, this is T and C. So as per for simply supported beam for A to E, value will be there. From A to B, value is 0. After that, B to D hinge support is provided, so diagram will be continue up to D point. Diagram will be continue up to D point here, and from this D to C we will close this. So this is the ILD for bending moment. Here value is how much? It is the value. Z
into
in bracket L minus Z divided by. So this distance is 2 meter, 2 meter, 1 meter and 5 meter. So Z is 2 in bracket L minus Z again 2 divided by 4. So value is, I think, 1 value will be there. Yes?
1 minute.
Yes. So this is 1. Now we have to calculate for this. So for 2 meter value is 1. So for 1 meter how much? So here value is 0.5. So this is the ILD for bending moment at Z, which is equal to 2 meter from A. This is first possibility. Now we will check second possibility if Z is in between B to C. Z is in between B to C. Second possibility we will check here. So I will write here for second possibility. Second condition is likewise Z at Z at 2 meter from 2 meter from D point, 2 meter from D, That means 3 meter from C. So this is second possibility. Okay. So for this first I will draw here original figure. So suppose this is original figure. This is A point. We will call this is B point and this is C. Here D point already we have located at 1 meter distance. Here at 1 meter. So this is A, B and C. From total distance this is 4 meter. From B to D distance is 1 meter. And now we have located Z distance at 2 meter from this D. So we will locate here E point and this is Z which is equal to 2. So remaining distance is how much? 3 meter. Okay, total see here. D to C span is 5 meter. Out of that we have given 2 meter up to E and remaining is 3 meter. So this is the case. We will draw ILD for shear force. आता इथं RA, RB आणि RC ची व्हॅल्यू चेंज होणार आहे का? चेंज होणार नाहीये. फक्त काय चेंज होणार आहे? shear force आणि bending moment. Because of the ILD for shear force and bending moment is depend on Z location. This all these three diagrams are depend on reactions. So reactions diagram does not change, only shear force and bending diagram, the bending moment diagrams will be changed. So we will draw here both possibilities. So this is D point, this is E point, and this is C point. Now we have to draw first diagram first for which point? कशासाठी ड्रॉ करावे लागेल? कुठल्या स्पॅनसाठी पहिले ड्रॉ करावे लागेल आपल्याला? फॉर डी टू सी. त्याच्यासाठी फर्स्ट ड्रॉ करून घ्यावे लागेल आणि मग लाईन्स एक्सटेंड करायला लागतील. बघा लक्षात आहे थोडे इकडं. बघा आता आपण डी टू सी मध्ये झेड पॉइंट प्रोव्हाइड केलेला आहे. ठीक आहे. इथं पॉइंट होते म्हणजे लक्षात येईल तुमच्या. दिस इज ए पॉइंट, दिस इज बी, दिस इज डी, दिस इज ई अँड दिस इज सी. आता आपलं झेडचं लोकेशन कुठल्या पॉइंटला आहे? डी पासून 2 मीटरला. म्हणजे डायग्राम डी पासून बिलो असणार आहे -z/l. तिथून डायग्राम कंटिन्यू असेल हियर आणि इथपासून ही सी ला 0 असेल. बरोबर आहे. आता इथून पुढे डायग्राम येईल का? आता इथे हिंज सपोर्ट आहे. हिंज सपोर्टला व्हॅल्यू नेहमी तुमची 0 असते. आता मी इथं क्लोज केली मग इथून पुढे व्हॅल्यू किती राहणार तुमची? 0 राहणार. जर इथं सिंपल सपोर्ट असतात तर डायग्राम पुढे कंटिन्यू झाली असती. If hinge support is provided at that hinge point, value will be 0. So diagram will end at that point. So this distance is 4 meter. This is 1 meter. This is 2 meter. This is 3 meter. So here Z by L, that is 2 by how much span? 5, which is equal to how much? 2 by 5. 0.4 and here 3 by 5 0.6 येते का? 0.6. So this is the ILD for shear force at Z which is equal to 2 meter from D. Then last diagram we have to draw here ILD for bending moment. So same way, first you have to draw ILD for which portion? D to C portion. Okay, so first we will mark point here. So this is A point, this is B point, C, this is E point, and last that is C point. Okay, so first we will mark in between. This is D. Point here. Okay, first we will mark for D to C. So D पासून Z लोकेशन पर्यंत काहीतरी व्हॅल्यू असणार आहे तुमची आणि Z पासून C ला ही डायग्राम काय होणार आहे? क्लोज. So here diagram will be closed. At hinge support value is 0. So for this B and A support again value is 0. That means ILD for bending moment is only likewise. Here value is how much? Z in bracket L minus Z divided by L. So which is equal to? So this distance is 4 meter, 1 meter, this is 2 meter and 3 meter. So 2 in bracket L, that is 5 minus 2 is 3 divided by 5. How much? 1.2.
1.2.
1.2. So this is the ILD for bending moment at Z, which is equal to 2 meter from D. So if indeterminate structure is given at that time, first you have to convert this indeterminate structure to determinate structure by providing hinge and then our regular procedure. So please take screenshots. So we will solve next example. If 2 hinges are provided, then how solve? 2 hinges चे एक्झाम्पल तुमच्या युनिव्हर्सिटीला नाही आहेत, पण गेटला किंवा कॉम्पिटेटिव्ह एक्झामला विचारलं जाऊ शकतं. कोण ड्रॉ करतंय?
मॅडम बॅक प्रिव्हियस पेज
बॅकचा काही प्रश्नच नाहीये, ती एक ह्याच्यावर सोडवलेली सगळं. काय म्हणताय केकन?
ते प्रिव्हियस पेजचं हे स्क्रीनशॉट करून घ्यायचं.
प्रिव्हियस म्हणजे ते पहिलं एक्झाम्पल होतं, ह्याच्यातलं कंटिन्यू नव्हतं ते.
मॅडम ते रिएक्शन कॅल्क्युलेशन
रिएक्शन मॅडम.
हा.
ओके मॅडम. Okay, now I will give one example for homework, or we will solve here immediately. Suppose hinge is provided at left side. Now this example, in this example, hinge is provided at right side. So we will see if hinge is provided at left side. How then solve this? So I will draw figure here. This is A point, suppose this is B and this is C. So here hinge support is provided in between A to B now, and this is C, and suppose here hinge support provided D, this 2 meter, this distance is 4 meter, and this total distance L, which is equal to 5 meter. Okay, so for this first you have to draw ILD for RA. कसे ड्रॉ करणार हो ILD for RA? रिएक्शनची काही गरजच नाहीये आपल्याला, डायरेक्टली इथे हिंज प्रोव्हाइड करून दिलाय. तुम्हाला डायग्राम ड्रॉ करताना रिएक्शनची व्हॅल्यूज टाकत नाही ना. हा, कसे ड्रॉ करणार ILD फॉर RA? बघा आता ही मी डायग्राम ड्रॉ केली. इथे A ला किती आहे तुमचा?
1.
D एक्सटेंड करू द्या, D एक्सटेंड करायचा राहिला. हा, फॉर A व्हॅल्यू इज 1. आफ्टर दॅट आता D ला हिंज आहे म्हणजे D ला 0 होणार आहे. तिथून पुढे डायग्राम येईल का नाही येणार. सो दिस इज द ILD फॉर RA. दिस व्हॅल्यू इज 1. दिस इज A पॉइंट, दिस इज D पॉइंट, B point, C point. This is 4 meter, 2 meter and 5 meter. So this is the ILD for RA. After that we will draw for RB.
आरबी ला कशी असणार आहे, कुठल्या पॉइंटला 1 व्हॅल्यू येणार आहे तुमची,
बी पॉइंट वन.
सो बी पॉइंटला 1 असेल. ओके, बी पॉइंटला 1 व्हॅल्यू आहे, तर त्यावेळी सी ला 0 असणार. सी ला 0 असेल, ते बी टू डी कंटिन्यू राहील आणि डी ला हिंज आहे तो 0 ला जात असतो, म्हणून ए ला ती 0 ला कंटिन्यू होईल. सो दिस इज द ILD फॉर RB. So this value is 1. This span is 5 meter. This is 2 meter and this is 4 meter. So for 5 meter value is 1. So 5 plus 2. For 7 meter this value is how much? 7 by 5. 7 by 5. This is A point, D, B and C. So this is the ILD for RB. After that we will draw. कुठे आता इथं कसं 0 होणार, आता बघा बी पासून डी पर्यंत तुमचा रिजिड ठेवायचा, बरोबर आहे. बी टू डी रिजिड येणार आहे, तो बी टू इथं डी ला 0 येतो, तो कुठे जाणार आहे तुमचा डी पर्यंत रिजिड होणार आहे आणि डी ला हिंज आहे ना, तिथून 0 कडे जात असतो. सो दिस इज ILD फॉर RB. देन वी विल ड्रॉ ILD फॉर RC. आता कशासाठी व्हॅल्यू 1 असणार आहे हो?
C.
Okay, so we will draw here ILD for RC. C साठी 1 असेल. For C value is 1. After that for B value is 0. Okay, B ला value 0 असेल, ती D ला तुमची कंटिन्यू येईल आणि D मधून कशाला तुमची क्लोज होईल, A ला. So this is the ILD for RC. 1 here, 0 that is B point, C point and this is A point. So this is the ILD for RC. ILD for RC. Then we will draw ILD for shear force and bending moment. So first we will draw beam here, original beam. So original beam is likewise suppose. So here simple support is provided. Here at B simple support is provided and B to C span is there. First we will extend all these lines. So we will draw easily all figures. Now we will mark Z point in between B to C. Suppose Z is at 3 meter from B. Z is at 3 meter from B and this is the D point. This is D point. We will write here points. This is A point. This is the D. This point is B. Here we will locate E, Z which is equal to 3 meter. This remaining distance is 2 meter and this is C. This distance is 2 meter. This distance is 4 meter. Now we have to draw ILD for shear force. So first we will draw in between B to C because of here simple support is provided. So from this B to E minus Z by L. After that diagram will go upward and from this it will close here. ह्याच्या पुढे कुठे येणार आहे तुमचा B to D रिजिड पार्ट असेल आणि D पासून पुढे कितीला जाणार आहे तो A ला 0 ला जाईल. So this is the ILD for shear force. Here A point, T, this is B point, E point and C. 2 meter, 3 meter, 2 meter, 4 meter. Okay, so here Z by L, that is 3 by 5. And here 2 by 5. So here for 3 meter, 3 by 5. So this distance is how much? For 3 meter, 3 by 5. So for 2 meter, question mark. किती येतं बघा हे डिस्टन्स 2 by 5 येते का चेक करा. बघा ह्या 3 साठी 3 by 5 तर ह्या 2 साठी 2 by 5. So this is the ILD for shear force at Z which is equal to 3 meter from B. Then we will draw a diagram for bending moment. So first we will draw for B to C portion. So from this B to E value will be there, and then E to C it will close. After that, for this B to D, we have to make a rigid portion. So diagram will go below here, and here diagram will close. So this is the ILD for bending moment. This is B point. Here, calculate this value. Z in bracket L minus Z divided by L. And here C point, this is E point, this distance is 2 meter, 3 meter. This distance is 2 meter, this distance is 4 meter. किती येते बघा हे distance? 6/5 येते का? 6/5 which is equal to 1.2. 1.2. मग हे डिस्टन्स किती येते बघा हे 3 मीटर साठी 1.2 आहे. तर 2 मीटर साठी क्वेश्चन मार्क. सो 1.2 into 2 divided by 3. One of the data. This is the one. So this is the ILD for bending moment at Z, which is equal to 3 meter from B. Z, which is equal to 3 meter from B. So if hinge is provided at right side, only this one 1.2 into 2, that is 2.4 divided by 3.
0.4 అయితే
0.8.
0.8.
This is the ILD for bending moment at Z, which is equal to 3 meters. So likewise, you have to solve. Now we will see last example. Suppose 2 hinges are provided, then how we will draw this diagram. So please take screenshots. Okay, draw this figure fast. Let me know after your drawing is over. So we will solve next example, that is if 2 hinges are provided.
Your writing is over. Yes.
Yes, ma'am.
Okay. So we will take last example. Draw ILD for shear force and bending moment if two hinges are provided. Okay. So I will draw figure here. So A, B, C. This is A point, this is B point, and this is C point. So this span is 4 meter, and here two hinges are provided. Suppose this is called as a T. This distance is 2 meter, and here E point. This distance is 2 meter, and this distance is again 2 meter. So we have to draw ILD for RA, RB, RC, then shear force and bending moment. So first we will extend all lines. लाइन्स एक्सटेंड करेपर्यंत तुम्ही थोडं आर ए ची ILD कशी ड्रॉ करायची ते लक्षात घ्या. कसं येते बघा सांगा जरा. कुठल्या पॉइंट पर्यंत येईल, कुठल्या पॉइंटला 1 असेल, कुठं 0 असेल. पुढे कुठं 0 असेल, कुठं 0 असेल. हा ऑनलाईन जे स्टुडंट अटेंड करतायत ते सांगा.
A ला 1 आणि B ला 0.
आणि ही मधली E आणि D. E आणि D ला काय असणार, एक लक्षात ठेवा, हिंज सपोर्टला 0 असतो, त्यामुळे A कडून E ला 0 आला, बरोबर आहे. आता E ला 0 आहे म्हटल्यानंतर पुढे डायग्राम इथं कॉन्स्टंट राहील. D ला किती असणार आहे, 0. B ला ऑटोमॅटिक किती आहे, 0. म्हणजे डायग्राम तुमची इथं क्लोज होती. सो दिस इज द ILD फॉर RA. Here value is 1. This distance is 2 meter. This is A, E, D, B, C. So this is the ILD for RA. ILD for RA. After that we will draw ILD for RB. So at B point value is 1. At B point value is 1 and at C point value is 0. Up to B point connection is closed. But from B to D we have to make rigid, so it will go up to D point. After that from this D to we will close at E because of that hinge support value is 0, and from this E to A again value is 0. So this is A, this is E, D, B and C. This distance is 4 meter, 2 meter, 2 meter, 2 meter. Okay, so this is one value. 4 meter साठी 1 आहे, तर 6 meter साठी किती, तर 6/4 किती येते बघा, 1.5. 1.5 and
ऑनलाइन स्टूडेंट वाला.
okay. So this is the ILD for RB. Then we will draw ILD for RC. कशी असेल RC ची, C पॉइंटला कुठल्या पॉइंटला 1 असणार आहे, C पॉइंटला. ओके, सो हियर 1 for C point. After that 0 for B point. After that from this B to D diagram will continue. Okay, and from this D to E point we have to make rigid here. So this diagram will be likewise. Here A, here E, this is a D, B and C. 4 meter. This distance is 2 meter. This is 2. This is 2. So here value is 1. 4 साठी 1 आहे, तर 2 साठी किती असेल ही व्हॅल्यू बघा.
This is 0.5. So this is the ILD for RC. Then last two diagrams are remaining, ILD for shear force and ILD for bending moment. So first we will draw original beam here, and then we will draw. We have to mark here Z location. Here Z location. Suppose this is up to this point, B point is there, and here P point. Now we will mark Z point in between B to C. In between B to C. So here E support is provided, hinge support here D, 2 meter, 2 meter, 2 meter. This is B. We will draw influence line diagram for shear force and bending moment. Last part is remaining, so we will draw fast. First, I will draw here original figure, and then we will draw ILD for shear force and ILD for bending moment. Please wait. I will draw here original beam. So here A, B, C beam is given. In that, at A simple support is provided. At B also simple support provided, and at C simple support is provided. In between A to B, there are two hinge supports are provided in between A to B. So this is B and this is C. So span for B to C is 4 meter. We will provide Z. Suppose this is called as F, and at 2 meter. And this is also 2. So this is Z, which is equal to 2 meter. Here one hinge support is provided D at 2 meter, and one hinge support is provided E at 2 meter. So this is original span. And for this, we have to draw ILD for shear force as well as ILD for bending moment. So we will extend all these points below. So we will draw proportionate diagram. Okay. Without extending this, you are able to draw, but this diagram is not proportionate. That's why we will extend these points. Now first we will draw for shear force. Okay, so here this is suppose baseline. Okay, and we have located Z at this. This is F, and this is B point, and this is C point. So for this simple support, from this B to F diagram is below Z by L. After that, it will go above and it will close to C. So this is the diagram for B to C. After that, from this B to D, we have to make a rigid figure. So we will continue up to D. But at D, hinge support is provided. So at D, diagram will be or value will be 0. So here value is 0. So diagram will close here. So this is D point, this is E point, and this is A point. This is 2 meter, this is 2 meter, this is 2 meter, 2 meter, and 2 meter. Okay, so here Z by L, that is 2 by 2, which is equal to how much? So Z by L, that is 2 by 4, which is equal to 0.5, and here also 0.5. Now for 2 meter, 0.5 distance is there. So for this 2 meter is, for 2 meter 0.5. So for 2 meter question mark. 2 into 0.5 by 2. So 2 get cancelled. This distance is also 0.5. So this is the ILD for shear force at Z, which is equal to 2 meter from B point. And then last diagram is remaining, that is ILD for bending moment. Same way, first we will draw for B to C portion, and then we will draw for remaining portion. So this is A point, this is E point, this is D point, here B point, this is Z point, we have located as a F and C. So for B to C, simple support is provided, and from B at 2 meter Z is provided. So diagram will go upward, and from this downward. After that, from this B to D, we will make rigid. But at D, hinge support is provided, so diagram will close here. Okay, so this is the ILD for bending moment. This is the ILD for bending moment at Z, which is equal to 2 meter from B. So here 2 meter, this is 2 meter. Here value is ZL minus Z divided by L. So Z is 2 into 2 divided by 4. I think one value will be there. Here 1. Okay, so for 2 meter value is 1. So for this 2 meter, I think again one value will be there. So here 1. So this is the ILD for bending moment. So likewise, you have to draw if 2 hinge supports are provided. But don't worry, in your university examination, this type of example will not ask. Only determinate structures will be asked. That means up to overhanging beam. Examples will be asked for your university examination. After that, we have solved with continuous beam. That is one hinge provided at right side, one hinge provided at left side, and 2 hinges. That examples are useful for GATE exam or any competitive exam. So now our unit number 8 is over. That means total syllabus of structural mechanics is completed. Okay. So we will take revision here. Okay, now we will take revision first for section second. In section second, there are how many units are there? 4 units. Unit number 4, 6, 7, and 8. Unit number 5 is shear force diagram and bending moment diagram. Unit number 6 is bending stresses in beam. Bending stresses in beam. Unit number 7 is shear stresses in beam. Shear stresses in beam. And last is the influence line diagram. So first we will start from unit number 5. In that we have studied what is meant by shear force. So shear force is nothing but algebraic sum of reactions or shear forces at various locations, either from left side or either from right side. Then we have discussed what is meant by shear force diagram. So shear force diagram is the graphical representation or connection of shear forces at various locations. म्हणजे shear force diagram कशावर डिपेंड आहे तुमची A पॉइंटला काहीतरी व्हॅल्यू असेल B ला आणि ते आपण कनेक्ट करत जातोय त्यालाच आपण काय म्हणतो shear force diagram. After that, we have discussed what is meant by bending moment and bending moment diagram. So bending moment means algebraic sum of all bending moments due to reactions or shear forces either from left side or either from right side. And diagram means graphical connection of various values of bending moment at their respective locations. After that, we have discussed some standard cases for simply supported beam. For simply supported beam, if simply supported beam, central point, simply supported beam, uniformly distributed load, simply supported beam, uniformly varying load, and simply supported beam, moment couple will be there. So for these 4 cases, we have discussed for simply supported beam. So if point load is applied at that time, shear force which is equal to W by 2. So suppose here W load is there and bending moment will be WL divided by 4. And the shape of bending moment and shape of shear force diagram is likewise. That means shape of shear force diagram is horizontal straight line and bending moment diagram is inclined straight line. After that, we have discussed for this uniformly distributed load. So for uniformly distributed load, shear force which is equal to WL by 2 and bending moment which is equal to WL square by 8. So here shear force will be likewise and bending moment is parabolic because of here x raised to power is 2. That's why the shape of bending moment diagram is parabolic. After that, we have solved for this uniformly varying load. So for this uniformly varying load, you have to remember shape of shear force diagram and bending moment diagram. Because of value will not ask, because of the values are in points. So shape of shear force and bending moment. So shape for shear force diagram is cubic parabola. Your parabolic shape will be there for shear force, and for bending moment shape will be cubic polynomial. युनिफॉर्मली व्हॅरिंग लोड साठी लक्षात ठेवा शियर फोर्सचा शेप आहे तुमचा पॅराबोलिक, कारण इथं x रेस टू पॉवर 2 आहे आणि बेंडिंग मोमेंटचा शेप आहे क्यूबिक पॉलिनॉमियल, इथं x चा क्यूब आहे. आणि देन मोमेंट कपल साठी मला वाटते हॉरिझॉन्टल लाईन आहे बिलो बेस लाईन, आणि तुमचं इथं काय आहे तर इथं पॅराबोला दिली. तर याच्यासाठी तुम्हाला काय लक्षात ठेवायचं की पॉइंट कड अप्लाय होत असेल तर शियर फोर्स हॉरिझॉन्टल लाईन and bending moment inclined straight line. Uniformly distributed load is applied at that time, shear force inclined line and bending moment parabolic. If uniformly varying load, shear force is parabolic and bending moment is cubic polynomial. Okay, so these shapes are very important because of definitely one question will be asked on these shapes and one question will be asked on these formulas. So this is the related to simply supported beam. Now we will move towards cantilever beam. So for cantilever beam, one end is fixed and other end is free. So suppose here load is applied. At that time maximum movement is at fixed end and zero movement at free end. Okay, at least that much you remember. After that we have solved numericals on these particular cases. And we have solved numericals on continuous beam also and overhanging beam also. So this is summary of unit number 5. After that we have studied at unit number 6, that is bending stresses in beam. Bending stresses in beam. So in that, first you have to remember, suppose this is the cross section of beam, here this is width and this is depth. So stress distribution diagram is likewise. Stress distribution is diagram is likewise. At neutral axis bending stress is 0 and at top and bottom fiber bending stress is maximum. So this remember. After that we have derived one equation, that is flexure formula. What is flexure equation? काय होतो flexure equation सांगा.
M by I
Yes.
sigma max upon y max
E upon R.
E upon R.
M by I, which is equal to sigma by y, which is equal to E upon R. So M nothing but bending moment or moment of resistance. I is moment of inertia. Sigma is stress oblique strength. If movement is there at that time, sigma is stress. If movement of resistance at that time, here stress is strength. This Y is the location of stress. E is Young's modulus, and last is R is radius of curvature. Radius of curvature. Okay, and we have solved numericals on this bending equation. After that, we have started unit number 7. Shear stresses in beam. Shear stresses in beams. So here cross section suppose rectangular. So shear stress distribution diagram is likewise. That means it indicates shear stress is 0 at top and bottom and maximum at neutral axis. This is the basic difference between bending stress diagram and shear stress diagram. ज्या न्यूट्रल ऍक्सिसला बेंडिंग स्ट्रेस 0 असतो तिथं शियर स्ट्रेस मॅक्सिमम असतो आणि जिथं बेंडिंग स्ट्रेस मॅक्सिमम असतो तिथं शियर स्ट्रेस 0 असतो. After that we have derived one shear stress equation tau, which is equal to SA y bar divided by IB. Yes, nothing but shear force A y bar, that is area into centroid of that particular section where you are going to find out shear stress. After that I means moment of inertia and B is the width of that particular section. Okay, and we have solved numericals on it. After that I think we have derived one equation, section modulus Z, which is equal to I divided by y max, that is moment of inertia divided by depth of neutral axis. And from this we have derived one relation for rectangular section and one relation for circular section. So maximum shear stress, which is equal to 3/2 tau average for rectangular section, and tau max, which is equal to how much? How much?
4/3.
4/3
4/3.
5.
tau average for सर्क्युलर सेक्शन. ह्या दोन्ही वरती मिळून एक क्वेश्चन विचारला जाऊ शकतो आणि ह्या दोन डायग्राम मध्ये एक क्वेश्चन असेल तुमचा. ह्या टाऊ ह्याच्यावरती एक क्वेश्चन असेल, फ्लेक्चर फॉर्म्युल्यावरती एक क्वेश्चन असेल आणि तुम्हाला झेड सेक्शन सेक्शन मॉड्युलस वगैरे कॅल्क्युलेट करायला सांगते. त्याच्यानंतर आपण हे बघितलं होतं की फॉर रेक्टँग्युलर सेक्शन झेड सेक्शन मॉड्युलस विच इज इक्वल टू BD square divided by 6. Because of moment of inertia is BD cube divided by 12, and after that divided by y max, that is T/2. So accordingly this equation will comes. For circular section Z, which is equal to pi/32 D cube will be there, section modulus, and I max is pi/64 D raised to 4. Okay. So that much points we have covered in bending stresses and shear stresses. Okay. Then last unit we have discussed, that is influence line diagrams. Influence line diagrams. So these influence line diagrams are applicable for moving loads. For moving loads. So in influence line diagram, location is constant, load is moving. And in shear force diagram, load is constant, location is moving. So this is the basic difference between ILD and shear force diagram. After that, we have studied some general cases for simply supported beam. For simply supported beam, the diagram for shear force. Suppose here Z section is provided. At that time, this is Z. Here it will come, and this is here Z by L minus Z by L, and here L, no, I think 1 minus Z by L. After that, for bending moment from this point to Z, value will be there and here, and this value is Z L minus Z divided by L. So these diagrams for simply supported beam. After that, we have drawn for cantilever beam. For cantilever beam, this is RA, this is MA. The value of MA is below baseline because of this MA pushes beam to downward. So MA, which is equal to minus X. So here minus L value will be there, and this is L, and this is 1, this is 1. After that, for shear force and bending moment, shear force and bending moment diagram कौन सकते हैं? Suppose Z point is here. सांगा, इथपासून ते इथपर्यंत 0 होती. इथपासून इथपर्यंत व्हॅल्यू तुमची 1 होती. So this is the ILD for shear force. That means X is less than Z and X is greater than Z. Here shear force is 0 and here 1. After that, we have drawn ILD for bending moment from this point to this point 0, and here something value will be there. काय होती ही value सांगा?
L.
नाही L नव्हती, Z minus L होती. बघा bending moment मध्ये Z minus L value होती. Z minus L correct आहे ना?
L minus Z आहे.
L minus Z. L minus Z मतलब डायग्राम above baseline जाते.
बराबर तर
Z minus L.
हाँ Z minus L. और L minus Z केलं तर L तुमचा काहीतरी 12 मीटर असेल, तर Z 6 मीटर असेल तर व्हॅल्यू पॉझिटिव्ह येणार आहे. डायग्राम above baseline जाईल. आपण डायग्राम काय केलेली आहे? बिलो बेसलाइन ड्रॉ केलेली आहे. सो व्हॅल्यू इज Z minus L. If you remember these figures, then you are able to draw diagram for overhanging beam. Because of overhanging beam is the combination of simply supported and overhanging.
मग त्यात काय करायचंय फर्स्ट यू हॅव टू ड्रॉ फॉर सिम्पली सपोर्टेड अँड आफ्टर दॅट ओनली यू हॅव टू मेक rigid beams. Okay, that much part we have studied it in unit number 8. So after that first section, in section first also there are 4 units, unit 1, 2, 3 and 4. First is simple stresses and strain, simple stress and strain. After that second unit is principal stresses and strains. This is combined torsion, bending and thrust, and last fourth unit is theories of elastic failure. So in this first unit we have discussed what is meant by stress, types of stresses, basically 2 types of stresses. First one is the normal stress and second one is the shear stress. Normal stress means force perpendicular to the cross section and shear stress means force along the cross section. If force is along the cross section, then shear stresses will be generated, and perpendicular to the cross section, then normal stresses will be generated. After that, we have discussed the strain. Strain is nothing but change in dimension upon original dimension. After that, volumetric strain, epsilon P, change in volume divided by original volume. After that, we have studied 3 constants, E, G, and K. E is Young's modulus, G is shear or modulus of rigidity, and K is bulk modulus. In these 3 constant, ratio is stress to strain. So for this E, direct stress or normal stress to normal strain. Here shear stress to shear strain, and here direct stress to the volumetric strain. That means stress to strain ratio will be there. After that, we have studied one relation E, which is equal to 9 kg divided by 3k plus G. Okay, after that second relation will be there. Kind of second relation E, which is equal to
2G in bracket 1 plus mu.
plus mu, and third relation is there E, which is equal to 3k
3
1 minus 2 mu. So
2
you
mu.
remember these 3 equations as well as these formulas. Also, the formula for stress is force upon area. Okay. And after that, we have discussed composite bars. Composite bars, that is bars in series and bars in parallel. So if bars are connected end to end or one over another, this is called as bars in series. And if bars are connected parallelly, then this is called as bars are connected in parallel. So this is the first unit. After that, in second unit, we have discussed major principal stress, minor principal stress, maximum shear stress, tau max. Okay, these formulas all you know that. After that, third unit is combined torsion, bending and thrust. And last fourth unit is theories of elastic failure. Okay, theories. In that we have discussed 5 theories. So you remember, for first theory, scientist. Second theory, for first theory, scientist is Rankine. For second theory, Saint Venant. Third theory is maximum shear stress theory. हाँ, कौन है maximum shear stress theory को develop के लिए?
Gust and Tresca, ma'am.
Gust and Tresca. But this theory is called as Gust theory. After that, fourth, Hayes theory. Hayes theory है ना? Hayes
Henry.
Hayes theory, and last is the Mises and Henke theory, and this is called as Mises Henke theory. So here you have to remember name of scientists. After that, the particular theory is applicable for brittle material or ductile material, and equations for each and every theory. So this is the syllabus we have studied it in structural mechanics 1. So today syllabus is over. If anybody having any doubt, any questions, then ask me by calling or meet me in college. I will clear your doubts. Please prepare for examination. All the best for examination. Thank you for attending lectures sincerely from starting. So today we will stop here. Thank you.